Okay, so these videos are short responses to the Kaplan book, the 2021 GED Prep Plus book, which is the best. The Kaplan book is the best. Go out and buy it. All we're doing here is going through the using the 46 questions of one of the practice tests just for subject area. And we're just going to tackle them one by one. This is a mixed number and fraction word prep with a picture. So it's hard to replicate what that is. The goal here is not to get we're not doing this to get those questions right. We're doing that just to after you take the practice test, along with all the stuff that's in the textbook or the book, just to talk it out a little bit. So I changed the numbers around a little bit about what's on question 4. But it's about making a fence. And the question really is about using mixed numbers, which is this. So here's the story, how it goes in the book. There's a railing of a fence that is a certain length. Okay, for our problem, we're going to say 42. They do something very tricky in the book that we'll talk about after we do this. But let's just say that this fence is 42 inches long, and the slats that touch perfectly, I don't have them touching, but they should, are 3.5 inches. And the question is, how many slats can you do in that? And there are 4 choices. So how do we approach this? So there's a couple different ways. One way is if each of these are 3.5 inches, whenever they start doing that and they start going to fractions or they start going to decimals or something like that, just pretend for a second that it's a whole number. Let's say each one of these boards was 3 inches. Nice, easy number to deal with. And the total length that has to cover is 42 inches. Then all we'd go is, this is 3 inch, and every time I add a new board, it gets longer. You know, I'm covering more of the fence area. How many of those boards, how many times am I going to put 3-inch boards down until I get to 42 inches? That's what times means for multiply. And since it's an unknown number, we put an X there. So 3 times something equals 42. This is my simplified version of it. And the simplified version is, well, if I want to figure out what X is, I got to get X all by itself. 3 times something is 42. So I'm going to put 3 downstairs. Now, what I mean by that is 3 times X. And the way to get rid of the 3 is then to divide it by 3. So X times 3 divided by 3 makes the 3's disappear. And we can do this. So we put the 3 downstairs because fractions are nothing but division symbols. Division symbol is nothing but a picture of a fraction. It's a line on top, a line with something on top and something on the bottom. So there's your times, there's your divide. Whatever we do to this side to be equal, whatever we do to this side, we have to do to this side. This will cancel out. The X comes on down. I always draw my fraction lines just a little bit too long to remind myself it's a division problem. So typing it into the calculator, 42 divided by 3 would give us 14. Now that would be nice, clean, easy math. But they didn't give us a clean number. They gave us 3 and a fraction, 1 over 2. So one way we could do this that's only the slightest bit different is change the 1/2 to a decimal. And if we can think in our head, hey, real quick, that's 0.5. Half a dollar is 50 cents. So right there, and we can drop the, if we did half a dollar is 50 cents, 3 and 1/2 is $3.50. Drop that 0, because that 0 doesn't do anything there. And now we just do the same problem and solve it the same way. 3.5 is trying to multiply. We're seeing how many times we put another board down or whatever, railroad track, whatever this thing is. Well, we want to get that X all by itself. The 3.5 goes down there. The 3.5 goes over here. We divide down. Always draw that tail too long. These two are going to cancel out. X comes on down. And then 42 divided by 3.5. Calculator's dying to do the question for us, so we're going to let it. 42 divided by 3.5 is 12. So that's how we could answer that. We could answer that by just changing the fraction to a decimal, and changing any fraction to a decimal if you wanted to do it. If you could type it into your calculator, it's that number, same as 3 divided by 4. If we had to do this by hand, you keep the clock going, and that's the number you kick out. So long division by hand, or short division by hand, or whatever, we'd have to put a point there and a point there, and then put a 0, and then do our division. So I'm going to erase this and that. This fraction, 3 over 4, is the same thing as 3 divided by 4, or if you have to, and that's how you type it into the calculator, or if we have to do it by hand, it's that way. So we just go clockwise. I'd much rather use a calculator, so that's what we try first. If this is one of the 5 questions where we can't use a calculator and we have to divide by hand, then we'll kick that bottom number out, and that's what puts that here. The 4 goes on the outside next to the 3. That's why the thing curves like that. So all of that to say, converting fractions to decimals is a division problem. But 3/4, if you could do that, that's 75 cents, 0.75. Now here's what they did in on the Kaplan problem that is something the GED does all the time. It was nice and straightforward how I wrote this problem. Like each of these boards is 3.5. But what they did is they had this being measured in feet and these being measured in inches. So what they do in there is they're putting a conversion in the middle of it. We got to convert from feet to inches, or inches to feet, or yards, or who knows. What we do in that situation, this number is already awkward to deal with. It's the smallest number. We would change the feet into inches. And somewhere on the question, it would say, remember, 1 foot equals 12 inches. That's what you multiply by. So it would be 12 times 12. 12 feet times 12 inches per foot would give us 144. And now that's the number we would use here. So that's why all I really wanted to point out about that problem on question 4 is GED will do that. They will have a problem about somebody, I don't know, going on a diet, losing weight. And then they'll give you their weight beforehand in pounds and how many percentage they lost and all this stuff. And then they say, oh, by the way, at the very end, figure out how many ounces that is. So at the end of the calculations, you got to go pounds to ounces. And it'll give you, 1 pound equals 16 ounces and stuff like that. But always be careful of the number they give you, because in the problem that is in the Kaplan book, if you don't convert feet to inches and just plug that number in there and you get an answer, and it's a very easy answer to find, it's also one of the choices and it's wrong. So they do that on purpose, and that's a great example of it on number 4. Where doing the wrong math becomes a choice. So dirty business. Not the easiest problem to sort of teach this way, but that's the thing, is learn to speak their language and how crooked they can be. On to question 5.